Today's session is about Norton's theorem. Today we are going to discuss some problems with dependent sources. So let's look into the first problem. Find the Norton equivalent network across the terminals A and B. A and B are these are the two terminals. Then first step is to find out Norton current IN. In order to find out Norton current, short circuit the terminals A and B. So I have redrawn the circuit like this. Terminals A and B are short circuited and the short circuit current IN. Now our aim is to find out this IN. Two mesh currents I1 and not I1, I2, IX and I1 are marked like this, and I2 is given in question. From this circuit it is clear that I2 and IX are same, so I am writing I2 equal to IX. Then this is current I1 which is also given in the question, and IX in clockwise direction, so we can write I1 equal to IY minus IX. Now applying KVL to loop 1. Applying KVL to this loop, so the equation will be 5 minus 10IX minus 5 into IX minus IY minus 10I2 is equal to 0. So the equation will be 5 minus 10IX minus 5 into IX minus IY minus 10I2 equals 0. That is 5 minus 10IX minus 5IX plus 5IY minus 10IX. I2 and IX are the same. Separating the terms of IX and IY. Separating the terms of Ix and Iy, so we will get the equation 25Ix minus 5Iy is equal to 5. It is marked as equation number 1. Then apply KVL to second mesh. While applying KVL to second mesh, the equation will be like this. We are writing the equation in this direction. So 10I2 minus 5Iy minus Ix plus 3I1 plus minus 10 Iy is equal to 0. Let's write the equation. 10I2 minus 5 into Iy minus Ix plus 3I1 minus 10 Iy equal to 0. 10 into I2 is Ix minus 5Iy plus 5Ix plus 3I1 is Iy minus Ix minus 10 Iy equals 0. Now separate the terms of Ix and Iy. So the equation we will get 12Ix minus 12Iy is equal to 0. Mark it as equation number 2. Now upon solving equations 1 and 2, we will get the values for Ix and Iy. Ix is equal to 0.25 ampere. After solving, we will get values for Ix and Iy like this. Now from this circuit, it is clear that this current is IN. IN is same as loop current IY. So we can write IN. Our aim is to find out IN. From the diagram, it is clear that IN is equal to IY. So we can write IN is equal to 0.25 ampere. Next step is to calculate Rn. And we know that in this circuit we are having both independent and dependent sources. So Rn can be calculated using this relation. Rn is equal to Vth divided by In. In we already got. Now we have to find out Vth. So next step is to calculate Vth. In order to calculate Vth, open circuit the terminals A and B. Then find out the voltage across A and B. For that, I am redrawing the circuit. In order to find out Vth, mesh current Ix is marked here. In this mesh, there will not be any current flow because A and B are open circuited. Now, apply KVL to mesh 1. While applying KVL to mesh 1, we will get the equation like this: 5 minus 10Ix minus 5Ix minus 10I2 equal to 0. And from this diagram, it is clear that I2 equal to Ix and I1 equal to minus Ix. I1 flows in upward direction and the loop current Ix in downward direction. So we can write I1 equal to minus Ix. So the equation will be 5 minus 15Ix minus 10 into I2 is Ix equals 0. So we will get 25Ix is equal to 5 and Ix is 0.2 ampere. 5 by 25. Ix is 0.2 amperes. Now we have to write the Vth equation. The Vth equation. Let's consider this loop. So it will be 5 minus 10 Ix plus 3I1, 5 minus 10 Ix plus 3I1. Then voltage drop across this resistor is 0. So plus 0. Then minus Vth equals 0. So we can write psi1 5 minus 10Ix minus 3Ix. I1 is equal to minus Ix. So this minus 3Ix is equal to Vth. So we will get Vth is equal to 5 minus 13Ix. Ix is 0.2. Is equal to 2.4 volt. Now calculation of R. Calculation of Rn. Rn is equal to Vth by In, that is equal to Vth, we got it as 2.4 divided by In, we already got as 0.25. So 9.6. Next step is to draw the Norton equivalent network. Norton's equivalent network, In in parallel with R. Then load RL is connected between terminals A and B. Let's move to the next question. Find the Norton equivalent network across terminals A and B. Here we are having a 15-volt independent source and two dependent sources. These two are the dependent sources. So first step is to find out Norton current IN. Terminals A and B are short circuited and the short circuit current is marked as IN. In the figure, it is clear that IN is the short circuit current and this 15 ohm resistor is in parallel with the short circuit. So this current will be 0 because 15 ohm resistor is short circuited. Across this 15 ohm resistor, we are having a short circuit. So the entire current will flow only through this short circuit path. So the current through this 15 ohm resistor will be 0. And in the question, it is given that that current is I2. So we can say here I2 is equal to 0. Then here we are having a dependent source 10 I2. As I2 is equal to 0, this will also be equal to 0. So the circuit will be like this. This source is removed. 10 I2 is equal to 0. So it is short circuited. So the voltage source is short circuited. Dependent source magnitude is equal to 0 because I2 is equal to 0. So 10 I2 is also equal to 0. So this source vanishes and the circuit will be like this. Now we have to find out IN. In order to find out IN, let's consider the mesh currents IX and IY. Then IN. For that, applying KVL to first mesh, applying KVL to mesh 1. So the equation will be 5 minus 5ix minus 8 into ix minus iy equal to 0. Now separating the terms of ix and iy. So we will get the equation as 13ix minus 8iy equal to 50. This is our equation number 1. Next step is to apply KVL to mesh 2. When apply KVL to mesh 2, equation will be like this. Minus 8 into iy minus ix minus 2iy equal to 0. Minus 8 into iy minus ix minus 2 into iy equal to 0. This minus 8ix plus 10iy equals 0. Equation number 2. Now solving equations 1 and 2, we will get the values for ix and iy. Upon solving, we will get ix is equal to 2.27 ampere and iy equal to 1.82 amperes. Now V1 from this diagram, okay, this equation, this is voltage V1. So from the diagram, we can write V1 is equal to, here it is plus, here it is minus. That means net current through 8 ohm resistor flows in this direction. So we can write current through 8 ohm resistor as Ix minus Iy. I repeat, this terminal is given as plus and this is given as minus. It is given in the question itself, which means net current flows through this direction. Net current in 8 ohm flows in this direction. If net current flows in this direction, that will be Ix minus Iy. Ix minus Iy into 8 is V1. That is equal to 2.27 minus 1.82 into 8 3.6. So V1 is 3.6 volt. And the question, this is 0.6 V1. So 0.6 V1 is 0.6 into 3.6. This will be 2.16. 0.6 into V1 is the same current IN. So we can write IN is equal to 0.6 V1. That is equal to 2.16 amperes. Next step is to calculate VTH. In order to calculate VTH, open circuit the terminals A and B and find out the voltage between terminals A and B. This will be VTH. Mesh currents are marked IX, IY, IZ. Now apply KVL to first. Applying KVL to first loop, equation will be 15 minus 5ix minus 8 into ix minus iy equals 0. It will be 39x minus 8iy is equal to 15, which is marked as equation number 1. Then apply KVL to mesh. Apply KVL to mesh 2, equation will be minus 8 into iy minus ix minus 2iy minus 10ix is equal to 0. So we will get the equation like this, minus 8ix plus 10iy plus 10i2 is equal to 0. It is equation number 3. Next is to apply KVL to the third mesh. It is clear that this current 0.6 V1 is same as I2. So we can write I2 is equal to 0.6 V1. This current is 0.6 V1. The entire current will flow through this path. This current is marked as I2. So we can write I2 equal to 0.6 V1. So I is equal to I2, that is equal to 0.6 V1. That is equal to 0.6 into V1 is voltage across this 8 ohm resistor, which is 8 into Ix minus Iy. So we got the equation like this, I2 is equal to 4.8 Ix minus Iy. That is 4.8 Ix minus 4.8 Iy minus I2 equal to 0. That's equation number 3. Now solve equations 1, 2 and 3 for getting the values of Ix, Iy and I2. While solving, we will get Ix is equal to 3.28 ampere, Iy is equal to 3.45 ampere, and I2 is equal to minus 0.83 amperes. Now, write the VTH equation. From the diagram, we can write the VTH equation like this. VTH, this voltage across A and B, will be same as voltage across this 15 ohm resistor. So we can write VTH is equal to 15 into I2. VTH is equal to 15 into minus 0.83 minus 12.45 volt. Next is calculation of RN. RN is equal to VTH divided by IN, that is equal to minus 12.45 divided by IN. We already got IN as 2.16. This is equal to minus 5.76. Next step is to draw the Norton equivalent circuit. Norton equivalent circuit is a current source IN in parallel with a resistor RN. If IN is 2.16 ampere, RN is minus 5.76 minus AN. This is the Norton equivalent circuit.